1 second. Yeah, so I'm just trying to write about, talk about one of these ideas that I've come up with. It's like a very efficient compression system. I mean, compression technique rather. I don't know if we can call it technique. Compression method rather. So what I'm see, I had thought about this initially. So see, what we all know what an abacus looks like. Sure, it's not an abacus necessarily, but it's like a matrix table. So something like this, but for the modern age. So what I'm saying is that you can present data in any form, but even in the binary form, I have thought of a solution to represent very large numbers. Sure, the what is it called? What to compress and decompress, is it? What is it called? 1 second. Compress. One second. Extract. Yeah, sorry. The extraction process itself will take quite a long time. Or what's it called? Decompressing rather. I would say decompressing. Yeah, so decompressing will take a long time. But what I'm saying is, even in the binary form, it can be represented in a very small way. And what I'm proposing is that, see, we all know how at least see. I was not very good at math when I was younger, but at least since 8th standard anyway. But we know how it works, how to square root something. So this same method based on the final binary data, even 100 GB of data. I'm just suggesting. So it will go from the last to the first digit based on some inversion. What is the word? Inversion filter. No, the data, final data, compressed data. Like the final, like imagine. I don't know, one of those games like Dirt 5 or Dirt 3 rather. Whatever sizes it is. Assume it is 100 GB. What we'll be doing is that we'll compress the entire installation file into a zip file, and whatever binary content of that is, we'll inverse this through some filter, the final content, and we'll apply a root to that final. It's sequential. So we don't have to take the whole number by itself. We'll do it step by step until we get to the final root. And then what we do is, so I had actually discussed it with, I'm sure it didn't understand. And see, whatever imperfections there are, sure, there's some confusion here. Don't be distracted. See, assuming the final number comes to assuming this was the original binary, zeros and ones, whatever, but the root itself gives the results like, it's nuanced. I'm sure you can understand. Sometimes the root itself goes beyond a certain number, but I'm saying like whatever the final, until we reach the reasonable ending, like the last few digits, the last digit rather, it doesn't need to be extremely accurate. So it doesn't need extreme precision to get the right answer until the last digit of the final binary data. We'll keep going, and the last number we'll use a, what is it called? What was it? Operator. It's like addition or something. So, and I mean, I hope you are able to follow through. And what I'm trying to say is, yeah, it's not this. Yeah, and I'll actually demonstrate it. Wait, I have a calculator. Yeah, so this is a binary generator. I created a random binary. It's 200 digits. And it's obviously very small, but I'm speaking very large scale. And so that is, whatever that is compressed here. And I'm speaking about a very large, like 100 GB. You can imagine how many digits there will be. But somehow we'll, digit by digit, we'll convert it to a square root like this. And then this will be squared further. Based on, see, it's assuming it's very simple, but sure. I don't know, you'll have to like work with it, but I know it's feasible based on what I know. But I don't think that. I think it's feasible. Yeah, it is feasible rather. Yeah. So we whatever last number is, we can just add an operator plus or replace the last digit before the decimal starts with 8 or something like that, so yeah, so we can do that, and we can do it in layers, like in an abacus or like in a matrix table, something like this. So whatever the final 100 GB data is will be represented in a table. It could be like 10 rows and 10 columns, something like that, but all the operators, etc., will be represented in a mathematical form, and all precision requirements will be put via operators, etc., and then see whatever that large content is, we can not compress, we can represent it in an abstract form like this, and then the system itself can interpret it layer by layer. Sure, it will take time, more than you expect, not too much time though, sure, but the thing is, this is feasible. You'll be able to do it, is from what I know. See, the only reason I'm saying it is because I don't have the means to do it by myself. Maybe I can try, but I just wanted to put it out there. I do think that, obviously. Yeah, so yeah. Yeah, so yeah, with this 100 GB of data, can you imagine all of that coming into a table like this? Yeah, I don't think that that's just because I'm skeptical. I'm open to expect errors, if anything, or that there can be nuances, and I'm pretty sure no matter what it is, it can be represented in this form. Yeah. Yeah, but the thing is, at the end of the day, the last value itself, it'll be something like this, and every other column, row and column will only have operators, the exponents and the operators to get the next rooted value, and that will get squared, and that will get squared until the final full binary value is provided, and then that can be exported out from the zip files. I hope you understand what I mean. Yeah, so that's what I think. I just wanted to put it out there so that it doesn't get, because how it is, things I say. Yeah, not that it matters either way, but I just wanted to put it out there. So yeah, anyway, what does it matters also again. But if anybody is interested in taking it forward, you can contact me or something. Yeah, like, see, I'm pretty sure this will be transformative in the computer industry also, for compressions. I've thought of a lot of stuff, trying to like put it up on video and stuff. Sure, you know about. All right, fine. So I hope you understood. Huh? Yeah. So that this can really compress not just these specific files, but the whole of internet archive can be represented like this. Sure, it will take time, a lot of time, but it can be done. Whatever information is important, progress of the human, like all our discoveries, inventions, all our scientific progress, human progress rather, can be represented in this form, and then we can write a formula or something that also works, and then they can just reinterpret that to read everything that is required in a very synthesized form, synthesized. All right. Oh, where is it? Where is it being streamed to, man? It's just Twitch, huh? Oh, I have to do that. I'll put it to YouTube via Twitch. Get the VOD from there. All right. Guys, later.